Now we are going to start with a compound that is plaster of Paris, that is POP, which is commonly called as POP. You know that first thing which I would like to share with you, because when I was a student, I used to think that why it is called as plaster of Paris. So does it belong to Paris? Or it has a certain kind of connection with Paris, right? Why only Paris, not America, right? So the reason is that actually, you know, the plaster of Paris just resemble a rock, a Portland rock, which is found in a Paris. So its name is being given, you can say, inspired by the name that is the Portland rock, which is found in Paris. So the name is just inspired by that Portland rock, right? So that is why it is called as plaster of Paris, right? I think it's a you can say a curious answer which I have given, because you must be thinking since long that why POP and what is this POP or plaster of Paris, right? Why, from where this Paris comes in chemistry, right? Because chemistry always revolve around the chemical substances and the chemical things, and now what you are going to what you are looking, that is the Paris, and everything you can just you can say assume the things happening in Paris. So just now get back to the topic. So again we have POP, that is the plaster of Paris. So we would be looking for the chemical formula first, because whenever we start with some chemical compound, we need to have the chemical formula. What is the actually constituent of that compound? So formula for this plaster of Paris is CaSO4 dot half H2O. As you already know that what is this H2O, as I told you, whenever you get to see this kind of H2O written with dot with the compound, that means it is a water of crystallization. So here the water of crystallization is a half water molecule, right? So that means one molecule of CaSO4 possess the half molecule of water of crystallization, that is the half molecule of water is in chemical combination with this calcium sulfate. Now when we talk of its this thing, the chemical name, it is calcium sulfate, half is written as hemihydrate. So it is calcium sulfate hemihydrate, right? So see, like one question I would like to discuss with you, because you often get in your paper, what you get a question that predict the formula for POP, and the option what you have is, just look at the board I'm writing here. So you have is, one is this, other is this, right? And suppose we have this. So when I ask you that like out of these three formulas, what formula is going to be for POP? So just look at the board. If we say this, so no, not this one, because here we have seen that half water molecule is shared by one CaSO4, and here it is indicating that two molecules are shared by CaSO4. So obviously it is not going to be correct. Right. Now look at this one. So look at this one first. So it indicates that one water molecule is shared by this calcium sulfate. So again it is wrong. The right one is this one. See, you must be confused that here I told you half and here it is 1, but still I am telling you that it is a right formula. See, because the reason behind is the same, it means the same. See, in this case what you get to see that half molecule of water of crystallization is present with one molecule of CaSO4, right? And here what is there? Here it indicates that one molecule is present with two CaSO4 molecule. So I think it's clear that here we are just telling that half molecule is shared by CaSO4, and here what we say that two molecules of CaSO4, that is calcium sulfate, shares one water molecule. So if like in an exam you encounter this kind of question, so just keep in mind this and this means the same, right? Here I am indicating the water molecule for one CaSO4, and here I am just denoting that two CaSO4 is sharing one water molecule, means the same, right? So this is what is the chemical formula for the plaster of Paris. So the common name is plaster of Paris, that is POP, and again what is the chemical name? That is calcium sulfate hemihydrate. And now you also know that what is the reason that why the name is kept POP, right? Now we are concerned with its preparation. Now as far as its preparation is concerned, so the raw material which is required to prepare this POP is gypsum. Right. What is the formula for gypsum? See, it is CaSO4 dot 2H2O. So what is the difference between the chemical form composition of gypsum and POP? It's only a difference of water molecules. That is, here we get to see half a molecule of water of crystallization, and here we get 2 molecules of water of crystallization. So difference lies in the number of molecules of water of crystallization. So we take gypsum, what we do, we heat it. When we heat it, we have to keep the check on the temperature, right? The temperature should not exceed 100 degrees Celsius, right? Or you can say it should not exceed 373 Kelvin, right? So that means that there should be a check on the temperature. Why? What is the reason behind the check? I'll be just telling you after completing this reaction. So for this moment, just keep in mind, we need to have a check on the temperature when we are heating this gypsum. So when we just heat it, what happens that when we just heat it, see 1.5 molecule of water gets evaporated and we are left with the half molecule of water. So as you all know that this specifies the formula for POP, so that means we have found our product which we were looking for, that is the POP, that is the plaster of Paris. Now the question is that why I told you to keep check on the temperature. See, if the temperature will exceed a particular limit, that means if the temperature will exceed the 100 degrees Celsius, what is going to happen? That means it will lose all its water of crystallization. I'll write temperature above 100 degrees, right? So what is going to happen when we'll just increase the temperature above 100 degrees? That means the all water molecules will just going to evaporate and we are left with anhydrous calcium sulfate. Right, and you know what is the name for this thing, anhydrous calcium sulfate? It is often called as dead burnt plaster. So that means we won't be getting our the compound which is similar to the Portland rock, that is the POP. We'll be getting something black color mass that is called as dead burnt plaster. So this is what like how we are preparing the POP. So again I'm telling you, just look at the board. We are just heating the gypsum. When we are heating, we have to keep the check on the temperature. It should not exceed 100 degrees Celsius, or if I talk in terms of Kelvin, it should not exceed 373 Kelvin. So as a result, what we'll get, we'll get POP, and along with that we'll get 1.5 water of crystallization will just get evaporated, right? And if the temperature is above that, we get a dead burnt plaster, right? So this is what is the POP. And you know that as far as its use is concerned, it is used in many things. See, it is used in making the decorative items, the toys or the show pieces which you get to see in market, right? So it is just used to, you can say it is one of the use that it is used in making those decorative items. And you know or you can say that it is serving one important use, and that important use is that it is used in joining the fractured bones. Right, so again I'm telling you that POP is used in joining the fractured bones. Just look at the board how it is being used. What we do, well, like when there is you can say a fracture in a bone, then and the doctor wish to join those bones, what actually he do? He make a mixture of POP and he mixes with water. That because POP is a powder and we need to mix in water if we want to have a solution, or you can say we want to have a viscous kind of thing. We need to dissolve in a minimum amount of water, right? Just to get a, you can say, a molten sort of mixture, right? So that means when we'll apply this mixture, so that means POP when reacts with water. So look at this reaction. When we remove water from the gypsum, it gets converted into the POP. So when we will mix it with water, so again that means it is going to form gypsum. So what happens when you just mix POP in water and just apply on that iron frame which is used to join the fractured bones, it gets slowly it gets converted into the gypsum. And this reaction is exothermic. A high amount of heat is liberated, right? So this reaction is somehow slow, but it is an exothermic reaction, and when this POP just combines with water, it forms the gypsum, and gypsum is very hard substance. You must have seen that if somebody is, like some of your friend is having a fractured bone or a fracture, so he cannot remove fracture on its own. That means, sorry, he cannot remove plaster on his own. What he has to do, he has to visit a doctor, and the doctor will be using a certain kind of tool to remove or to cut that plaster, because that plaster is something very hard, and you know that what is the constituent of that plaster? That is gypsum. So I think you can recall that how hard is it, right? So gypsum is very hard substance. So this is what is the use, that how the POP is used for joining the fractured bones. It is one of the important use. And one more thing, you must have encountered that it is a latest technique which is used in decorating the houses, that we have a kind of fall ceilings and all, and it is all done with the help of POP. So POP is just you can say it is just helping us in many ways, as it is joining our fractured bones, and also it is making decorative items, and also it is decorating our ceilings and roofs. So it is just serving an important use, right? So this is what is the POP.